In this video, we're going to be learning about the most important and most widely used organization system for classifying and categorizing elements based on certain aspects of their atomic structure, which is what we call the periodic table of the elements. Although if you just use the word periodic table, any scientist will know what you are talking about. And the periodic table of the elements looks something like this. You'll notice that I've written an arrow that moves from the left-hand side to the right-hand side because that actually tells you how to read the periodic table. So we read the periodic table just like we read English, starting at the top left-hand side here, and we can find the first element on the periodic table, which is easily identified with the name of the element here, which is a very common and very useful element called hydrogen. So this number here is what we call the atomic number, and the atomic number is used to organize elements in a very predictable system. So hydrogen is atomic number 1, and if we go over to the right-hand side, we can find atomic number 2 is helium. When we get to the end of one row of our periodic table, we go to the next row, and we find element number 3, which is lithium, element number 4, which is beryllium, and so on and so forth. So the atomic number is used as the primary way to classify elements based on the structure of the atoms of this element. For example, hydrogen, we know of, has 1 proton because the atomic number, let's actually get this in writing here. So the atomic number, which we can use the short form number sign here, is the way that elements are classified because it's an easy way to learn about the nucleus of an atom, because we can look at this number here and instantly identify the number of protons that hydrogen has. In fact, we can write that in like this. So if we draw hydrogen's nucleus, we can put the H, which is the short form for hydrogen, what we call the chemical symbol, into the nucleus like this. And because the atomic number tells us the number of protons, we can write 1 P plus, because remember from the previous video, protons have a positive charge, so we use P with a small plus sign here as the short form for protons. Now, the atomic number also tells us the number of electrons under normal circumstances, because normally if we look at an element, the number of protons, and remember of course that electrons are not actually found in the nucleus, they are found in shells around the nucleus. Under normal situations, the number of protons and the number of electrons that an atom has is actually equal, and because the amount of positive charge that an element has, hydrogen has 1 proton, and the amount of negative charge that an element has, hydrogen also has 1 electron, is actually equal. And as we can see, positive 1 minus 1 is 0. 0 is neither a positive number nor a negative number, and so we can show that this atom is neutral, and this is how atoms are represented on the periodic table. And in future videos, we'll look at what happens when the number of protons and the number of electrons is not the same, but one step at a time. Now, we have the atomic number that tells us the number of protons and the number of electrons. We have the chemical symbol so that we don't need to write the word hydrogen over and over again if we're looking at complicated structures. We have the name of the element so that we don't need to remember how to spell it. We can just look at the periodic table, and the final number, which in this periodic table is given to 2 decimal places here, is what we call the atomic mass. And the atomic mass actually tells us what the mass of an atom's nucleus is, because remember that electrons have a mass that is approximately equal to 0, because electrons are very small. And therefore, we can find the atomic mass by thinking of what is in the nucleus. Well, we know from our reminder here, because I put it right into the nucleus here, that protons are found within the nucleus. So part of the atom's mass is going to be based on how many protons are found in the nucleus. But of course, remember that the nucleus also has neutrons within it, and if we take the number of protons and the number of neutrons and add them together, we should find what the total mass of the element is. There's just one problem. The number of protons and the number of neutrons needs to be a whole number, meaning that we can't have decimal numbers here. Again, you'll learn in future grades where the decimal number for atomic mass came from, but for now what we need to do is round this to a whole number. So when we round, remember we're looking to see if 1.01 is closer to 1 or if it's closer to the next number up, which is 2. Obviously this isn't true. 1.01 is closer to 1, and so we say the atomic mass of hydrogen is basically equal to 1. Now we can find the number of neutrons that hydrogen has by taking the atomic mass and subtracting the atomic number, and that will give us the number of neutrons, because once again, if the number of protons, which is equal to our atomic number, and the number of neutrons add together to give us the atomic mass, then we can simply take the mass and subtract the atomic number to find the number of neutrons. And with hydrogen, this is quite simple. Hydrogen has a mass of 1. Hydrogen also has 1 proton, and therefore hydrogen actually has 0 neutrons in its nucleus. However, this is not always true depending on what the element is. So let's practice by reading the chemical symbol for titanium. So titanium is a metal that is used in making vehicles, especially aircraft, because even though titanium is quite light as a metal, it is relatively flexible and also relatively durable, which is why it is very commonly used in aircraft construction. Anyway, titanium is an easy element to find the symbol because the first 2 letters of titanium are Ti, and that's exactly what the chemical symbol is here. We can use the atomic number to tell us the number of protons and also the number of electrons. So titanium is going to have 22 electrons as well, but we don't know what the number of neutrons is directly because we can't look that up. So instead what we do is we take the atomic mass and round it to the nearest whole number. We recognize that 47.87 is closer to 48 than it is to 47, and therefore we have found our atomic mass, and now all that we need to do is take our atomic mass and subtract the number of protons. If we do some quick math here, be sure to check my math, and we can find, assuming I've done my arithmetic correctly, that titanium will have 26 neutrons and 22 protons. And the way that we can double check this, if we take the number of protons and the number of neutrons that we just calculated, and if we add them together, 2 plus 6 is 8, 2 plus 2 is 4, we should get the atomic mass that we started with, and that's how we know that our number of neutrons calculation is indeed correct. Now we're going to try this again, but we're going to use silver here because silver is a very good example of an element whose chemical symbol is not obvious. So silver's chemical symbol is Ag, even though the name silver has no A nor G in it, and that's because the name of silver, or the chemical symbol rather, is actually based on the name of silver in a language that isn't English. So in Latin, which was the language used by the Roman Empire, of which silver was used to make coins, I spelled that improperly, the name for silver is pronounced argentium in Latin, which is where the French word argent, which literally means money, comes from. So that tells us a little bit of the history of the element, because silver, of course, was used for currency in the Roman Empire. They would make coins out of silver, and that's why it's given the chemical symbol Ag. Other than that, the rest of the periodic table works the same way. We take the atomic number to find the number of protons and also the number of electrons. Remember, the atomic number tells us both protons and electrons. We take our atomic mass, 107.87, and we recognize that this is closer to 108 than it is to 107, and then all we need to do to find number of neutrons is to take the atomic mass, 108, and subtract our protons from that in order to find the number of neutrons. So 8 minus 7 is 1, and 10 minus 4 is 6. So that means that silver should have 61 neutrons. And if we just want to be absolutely certain, we can take 61 and add it to 47. So taking the number of neutrons and the number of protons together, put them back together. 1 plus 7 is 8, 6 plus 4 is 10, and that gives us our rounded atomic mass, which means that we did the neutron question correctly. Now, before you move on to the next video, you can try the practice problems below. The practice problems below are designed to check and see if you can use the periodic table to find what the chemical symbol is of an element, what the element name is based on its chemical symbol, and to use the information to learn about the atoms. So can you use the periodic table to find how many protons and electrons an element has, how many neutrons it has based on the atomic mass, and of course, can you match this information to the element name and chemical symbol below. And in the next video, once you're certain about this, we're going to take a more detailed look at how the periodic table is organized and learning about some of the groups of elements together and why these elements are grouped together into specific element families.